Hi folks, I hope you enjoy all these videos. Please do not forget to subscribe. Please also share these videos amongst your friends and colleagues. Please do like them. Thank you.
In the previous module, we have seen IS-95 system and its architecture. In this current module, we will talk about CDMA 2000 system and its architecture. What are the things we will see in this particular module? We will compare CDMA 2000 and IS-95, of course. What drives this evolution? What is new over IS-95? Then we will deal with CDMA architecture in detail, the network, the elements, systemic and functional, the RAN network, the packet network, the core network, the architectures of EVDO and EVDV, and also SMS architecture. Then we move on to the channel structure, the forward channels that are there in CDMA 2000, what is new over IS-95 in terms of channels, the forward link main channels, pilot, sync, paging channels, and the traffic channels. We will also see different spreading rates and different radio configurations. Then we will move on to reverse channels. What's the structure of reverse channels in CDMA 2000? The access channels, the enhanced access channel, traffic channels, and comparison between forward and reverse channels. Okay, let's move on and learn more about CDMA 2000 system and architecture. What drives this telecom evolution? Some of the main requirements for a technology to evolve are listed below. First one is multimedia capabilities. The next generation mobile network should primarily support video applications in a big way. Audio, music, images, movies, video, data, and so on. Next is high-speed data. Broadband speeds of 256 kilobits per second to 2 megabits per second is a must. Voice as an application is taken for granted nowadays. No one talks about voice as a serious application anymore. Quality of service. This will be as specified in 3GPP2 standards, which is the pioneering standards for CDMA, and this needs to be strictly adhered to, and enhanced applications are inbuilt into the next generation network. Packet-based video telephony. Video is a very popular demand, as we all know. Video will take the packet switching route so that the tariffs crash. VoIP. Voice also will take the packet route through well-managed internet so that tariffs crash. Example will be a gaming application. Instant multimedia, voice, video and data applications. Broadcast and multicast. We can give a few examples here. For example, a cricket match or a football match being relayed live, or movies, videos, streaming on demand or while being broadcast. These are some of the broadcast and multicast applications. These are the kind of applications which will drive technology and lead to telecom evolution from 2G to 3G to 4G. Even 5G is being talked about nowadays, and actually we do not know the destination. It's a continuous journey of evolution. Let us see some more aspects of what drives this evolution. Let's look at the figure on the screen now. A quick recap of all the evolution parts in CDMA is seen here. By now, the reader is quite familiar with both technologies, the business drivers, and the applications. IS-95A and 95B have been discussed in detail in the previous chapter. We will discuss CDMA 2000 in detail in this chapter. CDMA 2000 is the 3G version of CDMA. We will not discuss the GSM evolution at all in this module. Let's look at this figure that's appearing on your screen. What is IS-95A? CDMA was commercially introduced in 1995 with IS-95A or CDMA-1. IS-95 is the CDMA-based second generation standard for mobile communications. We have seen all these things already, but nevertheless it can be one more revision. As already seen, the following are the key aspects. Supports data up to 14.4 kilobits, 1.25 MHz bandwidth, supports 20 to 35 users. IS-95 has been used exclusively for circuit switched voice. Convolutional channel coding is used. Modulation techniques such as BPSK and QPSK are being employed. IS-95 system was the first CDMA system on a commercial basis. It supports voice predominantly, and the maximum data rate that is possible is 14.4 kilobits per second. These are the two important points of note in IS-95. But please note that this was the first CDMA system which was proved on a commercial basis as a viable technology. Next step in the evolution was IS-95B. This is designated as 2.5G. IS-95B maintains the physical layer of IS-95A, but due to an enhanced MAC layer, this is capable of providing higher data speeds. Following are the key aspects of IS-95B standard. 1.25 MHz bandwidth, can support 20 to 40 users. Theoretical data rates can go up to 115 kilobits per second, but the actual experience will be typically about 64 kilobits per second. Additional Walsh codes and PN sequence masks which enable a mobile user to be assigned up to 8 forward or reverse code channels simultaneously, thus enabling a higher data rate. How IS-95B got up to 115 kilobits per second, whereas 95A was only at 14.4 kilobits per second. The secret is that 8 forward channels or 8 reverse channels can be simultaneously allotted so that it becomes 8 into 14.4, which is about 115 kilobits per second. Convolutional channel coding is employed. BPSK and QPSK are the modulation techniques. Access network is improved over IS-95A. The handoffs are much smarter than in 95A. The next system is CDMA 2000 1X. Supports 1.25 MHz bandwidth, supports 59 users, supports data rates up to 307 kilobits per second, with actual experience being around 144 kilobits per second. A new channel called QPCH, Quick Pilot Channel, is introduced in CDMA 2000, which improves the battery life. Additional radio configurations have been introduced to provide for additional data rate. Quality and erasure indicator bits QIB and EIB have been introduced so that lost frames can be retransmitted. The code channels are transmitted at full data rates during data burst. Convolutional and turbo codings are used. Modulation technique is QPSK. The access network is improved further. The channel structure is enhanced for quicker access, higher data rates, and more number of simultaneous network users. In the 3G space, the next evolution was 1X EVDO, evolution data optimized. Some people call it data only, but I think data optimized is a much more accurate description of the system. Supports 1.25 MHz bandwidth, supports 59 users. Data rate can go up to 2.4 Mbps. Wow. Unfortunately, this has no backward compatibility with CDMA 2000, and this can handle only data, and that too in an all IP environment. Therefore, EVDO is really a standalone system and has no compatibility with the rest of the CDMA flavors. Provides macro diversity via radio selection. We'll talk about macro diversity in detail as we go along. Uses a multi-level modulation format, QPSK, octal PSK, and 16-bit QAM. It can support high data rates, but it can support only data. No voice support is possible in this. That's a serious limitation, apart from the system being incompatible with the rest of the CDMA flavors. The next evolution is 1x EVDO, evolution, data and video. The limitations that were found in EVDO have been removed in this evolution. 1.25 MHz bandwidth. It is backward compatible with CDMA 2000 and the other flavors. EVDO can be easily extended to operate in 3x mode also. Forward data rate is 3.072 Mbps. Oh, this is even better than EVDO. Reverse peak data rate is 451 kbps. Addition of 3 new channels to forward link and reverse link for packet data operation and its support. Adaptive modulation coding, QPSK, octal PSK and 16-bit QAM. It supports variable frames. Mobile station can select one of the N base stations. DTX transmission supported for saving battery life. Highest data rates, and this can support data and voice. Please note, EVDO could support only data and no voice, whereas EVDO can support data and voice. Next comes CDMA 2000 3X, not very popular. 3X uses 3 times 1.25 MHz bandwidth, that is a bundle of 3 carriers, and supports 120 to 210 users. The capacity also becomes treble. Offers data speeds up to 2 Mbps, that's really a whopping speed. Uses 3 standard 1.25 MHz channels within a 5 MHz band. Uses convolutional and turbo coding techniques. QPSK is a modulation. Supports faster data rates.
Hi guys, hope you have enjoyed this video. Before you leave this, please ensure that you are subscribing to this. Also, please do like these videos and share it amongst your friends and colleagues. There are plenty of other videos and I hope you will be able to find time to browse through all these things. Thank you.